So welcome back to another episode of the Programmer Hour podcast. And today we have a very special guest with us. Don't we, Pranav?
Yes, today we have the DevOps Directive. He's a freelancer, a YouTuber, a social media sensation, and whatnot. He covers everything related to Docker and Kubernetes on his awesome YouTube channel, which is obviously linked to the description below.
In addition to that, we also covered some coding fundamentals and his journey from mechanical engineering to a computer science engineer.
Which is pretty awesome, to be honest. And there are many people who want to switch their careers, and this is a total 360 degrees because mechanical and computer science are totally different. So if you are in the same boat, this episode is just for you.
And I believe that there comes a point in every programmer's career when they need to understand the fundamentals of DevOps. So this episode will be really great and informative if you're at that point. So what are we waiting for? Let's get right into it.
So first of all, welcome. Welcome and thank you very much for sparing some time for the podcast. So we started a new series where we intend to know more about you, and I'm sure that you guys will drop in a few gems while talking and while we get to know you more.
Yeah, here and there. So people can learn from your experiences.
Exactly. So first of all, we know you because you have helped us when you were helping us host our Discord bot on AWS. So we know a little bit about you, but can you please introduce yourself to the audience?
Sure. My name is Sid. Here on YouTube, I go by DevOps Directive. That's the channel name that I run. It's all focused on DevOps and cloud infrastructure topics. So I started my career as a mechanical engineer, shifted into software, and then really for the past few years have focused on DevOps and cloud infrastructure. And right now work as an independent consultant for a variety of companies, sort of helping them with their DevOps story and building out their cloud infrastructure. And then on YouTube, I teach those topics, and it ranges from short form content, like 5-minute quick tutorials that really try to hit and condense the information so that you can consume it very quickly, all the way to long live streams like the one you're referring to, where I'll hop on a pair programming session with one or more people and try to solve some DevOps or cloud infrastructure challenge together. So it's been a fun journey, and happy to be here. Thanks for having me on.
Thank you for accepting our invitation.
And did you start TikTok videos, by the way?
I had TikTok. I haven't done much in a long time, but sort of the beginning of 2020, I had TikTok was my handle, and I made a few short videos, but I haven't explored it more.
Okay.
Yeah, I think it's the same for us. We do have a TikTok profile for the immigrant programmers as well, but like we really need to work on it. And we don't. I'm not even sure if we have like any posts there.
So we YouTube introduced shorts, so we keep on creating some shorts, and if we don't forget, we try to upload them on Instagram and TikTok. But so if we have 10 shorts, 5 of them go to Instagram and maybe 1 go to TikTok. So
sounds like you need to automate it. Sounds like you need to add a little DevOps to this video production process.
Exactly. So there's another episode of DevOps Directive.
All right. So we know that you have a YouTube channel, as you just mentioned, and we've been following your YouTube channel as well. And what we want to know is what does your life look like outside of YouTube? So like, do you have a W-2 income as well? Are you a freelancer? Tell us a little bit about that.
Sure, yeah. So on the work side of things, I am a freelance contractor. So in the US, that's a 1099 is the alternative to a W-2. And so I work mostly with startups, and I have one client that I've been working with for quite some time, and then a few smaller projects over the past few years, where basically they hire me part-time, usually between 10 and 20 hours a week, to help them with their cloud infrastructure. So in one case, it was helping to roll out a new platform on top of Kubernetes. In another case, it was adding CI/CD to all their applications, et cetera, et cetera. So it really runs the gamut. I enjoy and focus on Kubernetes related projects the most. But yeah, my income is through those projects, and then a little bit of income through the video stuff as well.
Okay.
That's yes, so we know that your YouTube channel just hit like 15K subscribers. So first of all, like many congratulations to you on that. And we would also like to know some secrets, some tips and tricks that you use to grow your channel. And
Sure.
So like, what do you want to share, like some strategies that you use that really worked for you that can like help other YouTubers as well? to grow?
Yeah, so my growth on YouTube, the growth curve is interesting because I started the channel, I uploaded my first video in February of 2020. I think I only had 800 subscribers in November of 2020. So most of that whole year was a very slow curve. I tried to upload every week, but I didn't necessarily always hit that schedule. Those videos at the beginning would get 10 views, 20 views. You know, you upload it and you're waiting for comments, you're waiting for a thumbs up. So and that's actually now one of my favorite parts of YouTube is finding newer creators and really becoming a super fan, commenting on their videos and thumbs up, and you know, because like each one of those interactions early on means so much. But so for my journey, about from February to November was 800 subscribers. I then had a guest post on the Traversy Media channel, which is a massive coding tutorial channel where I did a 1 hour DevOps crash course where I accelerated, I Dockerized an application, I deployed infrastructure with Terraform, and then I added GitHub Actions for CI/CD, and just it was like hyper speed in 1 hour. I think the recording was probably 2.5 hours, and I edited it down to 1 hour. And so some people actually complain that it's too fast, but I really wanted to hit that 1 hour mark. But so that gave my channel a big boost where I think I doubled or tripled my channel from that, where people who watched that then came over to my channel and some of them subscribed. So that was a big win in late 2020. And so then
did you put the 1 hour limit on yourself, or was it by
Traversy Media channel?
I put it on myself. I was working on the edit and it was, I don't know, maybe it was getting close to an hour. And so I figured, why not really trim it down and hit that 59-minute mark?
Because I think a nice thumbnail and nice title.
Exactly. Yeah, exactly. So that was a big win. I then had a video a few weeks later, which is actually slightly outside my niche, but the Apple M1 chip had just come out for their new MacBooks. And I put out a video explaining a few hesitations I had as a software engineer in terms of software compatibility and limitations with soldered on RAM, the maximum quantity, et cetera, et cetera. And that video just immediately took off.
We saw,
the M1 chip.
That was the first video. That's how we came to know that there's a channel called DevOps Directive. And since we saw that video, YouTube algorithm, the almighty algorithm has been showing us your videos since then.
Yeah.
Nice. So that one took off immediately, brought a ton of subscribers, a lot of new people to the channel. And so that was another big win in late 2020. And then since then, it's been steady growth. I just recently had another video do quite well. My GitHub Copilot video took off and now is, I think, at 150,000 views or something. And so, I've tried to post consistently just to increase the surface area of luck. So the more swings I take, the more likely it is that I'll hit a home run. And so with each one, I try to get slightly better than the one before and just try to put out content that I'm excited about and I think my audience will be excited about. That's really all there is to it.
That's awesome. And I saw your GitHub Copilot video as well, and it was really scary.
It was so scared. It was really
because it was awesomely scary. So it's not in a negative way, but in a positive way, because you literally copied a lead code problem, and in a second it was able to give us the right answer. And you said that behind the scenes you tried it a few more times, and sometimes it gave a completely wrong algorithm. But still, it's pretty impressive. Like, I'm so impressed on how it is able to infer from what is written, so basic language, and it's able to interpret the question. Because if it was just in 1,000 inputs and 1,000 output, and then it works its way around, I could have understood that it's some kind of machine learning, and it's learning what kind of input should be transformed in what kind of output. But that was just amazing how it works. And
that one's really interesting. And one thing I did not point out in the video that a number of comments have pointed out, I think some of them get the point, some of them miss the point a little bit, is that it is true that LeetCode is a very popular platform. Many people solve those questions and put the answers into public GitHub repos that were likely used in the training set for GitHub Copilot. That makes it slightly easier for the algorithm. However, I still think it's really impressive that it was able to find the exact right solution, even if the value is in the training set. There was some interesting research done right after the algorithm came out and the system came out around how often it was basically parroting back code that it had already seen versus synthesizing new code based on the inputs that it provided.
Okay.
And the research found that it was quite rare that it would actually parrot back something exactly that it found. I've also seen other anecdotal cases where it was parroting back like exact comments from, I think, the Doom code base or something kind of ridiculous, where it was so unique, like these comments would not be found anywhere else. It was clear that it was parroting back specific sentences. So yeah, it's interesting to think about like when it is just regurgitating something that it saw in the training set and when it is synthesizing new information. And I think the leak code example is somewhere right on that boundary where it's like it's unclear exactly which of those two it's doing, and that makes it kind of interesting.
Yeah, and I did try to register for GitHub Copilots, but I'm still in the wait list. So when you put the lead code question in, is it like a split second and it gives the answer, or does it take some time and you cut that part out of your videos?
No, it's literally about 1 second to give you a suggestion. That's and then you can open up, and I didn't do this, but you can open up a tab and it gives you the top 10 choices. And so sometimes it would be incorrect or not exactly what you want, but then you can pull up the list of choices and say, oh, number 3 looks good. Or at the very least provides an interesting starting point so that you're not typing out a bunch of boilerplate.
That's pretty good.
As scary as it sounds, as it might sound to like the developers, but I think the point that you mentioned at the end of the video, that like when you go and when you write code for a company, like at your job, if you're a developer, you don't just like have to solve an algorithm problem. There's a lot more other things involved. There's like user requirements that you really need to understand. There's some like prior knowledge that you already have about the context that you need to apply while writing the code. So I mean, as scary as it sounded, but like at the end it was all good.
Yeah. We still have our job for a couple of years.
And I think to take that point you were just making even further, not only do you not only solve algorithm problems, when you do encounter an algorithm problem on the job, you Google it or you look it up and have a reference there, and you're not expected to implement each individual algorithm from scratch. And most of the job is not that. So I think there's a few points still on our side.
That's true.
Exactly.
So maybe 3 years, not more than 2. Okay. Moving back to your background a little, otherwise I'll just keep talking on how GitHub Copilot is going to take our jobs. So you said that your background is in mechanical engineering, and I have mentioned this to you a couple of times before. That is so fascinating for me, that because mechanical and computer science are totally different fields. So how and why did you get started into mechanical, and then how did you get into computers from there?
Sure. So when I was 18 and going off to college, I knew that I was good at math. I was good at science. I enjoyed building things. And so those 3 things sort of came together into what I thought made a perfect match with mechanical engineering. I don't think I really understood at that point in time what engineering really was, or what a mechanical engineer did versus a software engineer versus some other discipline. And so doing the fuzzy match of like these 3 things mean X, I came up with mechanical engineering, and I really enjoyed that degree. I went on and got a master's degree in mechanical engineering as well. Then went off into industry and spent 5 years as a research engineer, research scientist.
So really went in deep.
Exactly. So I spent a good portion of my life as a mechanical engineer doing mechanical engineering things. I will say that the discipline within mechanical engineering that I focused on, which was control systems, is more on the software side of things. It's kind of at the intersection of physical systems and software systems, and controlling those two, or controlling the physical system with the software, right? And so I had exposure to that, even though I hadn't formally studied computer science in school.
Okay. So makes sense. But so when you first dived into computer science, or like, was DevOps the first thing that you did, or did you learn programming?
Did you try out like other domains in computer science as well, like web dev or mobile dev, anything else?
Yeah. So in my role as a research engineer, I was writing software in the sense that it was a lot of MATLAB and simulations for these control systems. So that was probably the first domain that I emphasized. Okay. When I decided to leave that role in 2018, I decided to go into web dev because full stack software engineering seemed like the most straightforward path to landing a job here in San Francisco. There's tons of startups, there's tons of big tech companies that are all building web applications, I think more so than any other discipline within software engineering.
And San Francisco is definitely one of the best areas to work in as a
full stack developer,
as a programmer of any field, I guess.
Yeah, I think so. And so I made that decision. During the time, I did some traveling and then came back and started applying to jobs. And so during that time, I read Cracking the Coding Interview and went through every question in the book and solved it on a piece of paper and then typed my answers into the IDE and checked that it worked.
Really worked hard. I have started that book. I am not lying. I've started that book like 5 or 6 times. And I'm never able to like go even 1/3. Like I might still be on page number 50 or 55.
Yeah, I think I made it about 2/3 of the way through doing every problem. And then there were a couple chapters towards the end that I trailed off. But that was hugely helpful coming from a place where I hadn't studied computer science. I hadn't done the deep data science, data structures and algorithms curriculums that many programs do. So that really helped me to close that gap and make myself at least reach the bar that was necessary to pass the technical interviews at these companies. So I did that.
I mean, if anyone kind of completes that book, I'm sure they would be able to crack almost any algorithm-related interview at least. So yeah, I mean, for sure, you were going to do that definitely.
I was still missing a lot of context about like what it even means to do web development. Like I could solve the algorithm questions, which is part of the technical interview. But then I remember this one systems interview that I had for one of the companies I had applied to, and effectively they were asking me how to work with a data set that was too big to fit into memory and or too big to store on one machine even. And I just like had no idea what to even go into, right? And kind of stumbled my way with the interviewer's help into this concept of sharding, where you need some key to decide which disk or machine that you're going to put the specific data on. But I had never even heard the term sharding until after the interview, and I went and looked it up. It was just really interesting coming from a non-software background and trying to pass these interviews and figure it out along the way. And so I was pretty good at the algorithm ones, but system-wise, I still was quite lacking at that time.
So you said that the jobs that you were applying for were like full stack positions, or they were software development? And
they were full stack software engineering roles. I mean, the people we can debate what those terms mean in terms of software engineering, full stack, back end. I use those three somewhat interchangeably within the context of a company building a web application. I don't know if you do the same, but yeah, I was focused on those because I didn't really have much. I had a little bit of experience on the front end, but not much. But I felt that my software experience from the prior role was most similar to back end development. And so, but I didn't have like the deep systems knowledge to be just a back end engineer, I thought. So I thought full stack is probably the right balance, at least to get started.
Okay, that makes sense. But why did you actually move? Like, I'm actually curious about that because was it that you were not enjoying mechanical, or there were a few jobs, or you just wanted to try something different?
There's a couple of reasons. I think the primary one is that I felt that the number of problems that I could address, or like number of things that I could personally take on, was much larger in the software domain than in the mechanical domain. And by that, I mean, if I just look around at like the types of problems in the world, there are things that you can build hardware to address. But I think right now, and over the past 15, 20 years, there's just been this massive growth where I forget who said it, but I think it was Mark Andreessen or something, that software is eating the world, meaning that just like you can build software to take the place of so many things that have historically been done manually. And so that idea that you can really scale your impact by writing code that can be run not infinitely, but close to it number of times is a pretty powerful concept. And I was really enjoying the software portions of my role, and so figured why not do that full time.
Yeah, that is one of the strong beliefs I have. I have also mentioned that in a YouTube short video, that I really think that in the upcoming years there are going to be a lot more programmers than there are today, because this is a field that is, I think, it has just started. I mean, I think more things are going to be automated, more programmers would be needed, and I think that the way we learn maths and everything, I think even schools will start teaching basic programming since the young age. Like I just think that's the practical way to move forward. I don't know, maybe I'm because from this field, that's why I feel that it's important. But
No, but it's true. It has already begun. Now we know that people like their people send their children to coding boot camps at a very young age, and they also have like coding. How do you call them, video games and stuff, so they have like coding games where they can like code in JavaScript. It's I don't know the language that kids use, but it's based on JavaScript, and they can create like their models, they can code and stuff.
That's true.
Yeah, I think there's been a push to add computer science to many curriculums at the high school level in recent years.
Yeah.
And not just software, but also emphasizing sort of data science or analytical capabilities as well.
That's true.
People are realizing how important it is for people to be number literate and have the ability to look at a set of metrics and build a strategy from them in a way that we didn't see some time ago, where I feel like many companies were less metrics driven and more intuition driven. And so I think more and more we're seeing data driven approaches to business and other domains.
And do you remember, I mean, when we were in Concordia University, we were doing our masters. I was trying to do tutoring on the side just to make some extra money. It didn't go well, but there was an MBA student who actually contacted me and said that she wants to learn Python from me, because everyone in the curriculum knows some basic Python or R for data science. And like I was surprised that, management fields, and then my brother, he's in the marketing field, and he's kind of required to know the basics of Python, R, and HTML, CSS.
And even databases. He wants to learn SQL database because
SQL is a superpower. I tell people this all the time, but like the amount of business questions that can be answered by knowing some beginner to intermediate level SQL and getting access to the database is pretty amazing. I remember at this startup that I was working at, we just had so many things that we needed to know about the business, how much each customer was costing us, what was the delay in processing time from the time we got these documents to the time that they were fully processed, et cetera, down the line. And so the best way to answer those was using data that was collected from the web application that we were using to do all this work. And so we actually, I ran a little like SQL lunch and learn to teach anyone to the company who didn't know SQL or wanted to level up their SQL, those skills, so that they could, and usually it wouldn't get them all the way there, but it would allow them to explore a little bit and get started with a query that then they might come to someone to validate, or to, I'm stuck on this particular thing, rather than just having to raise their hand and say, help, I need an answer. Like, someone write me this query? And so, we were able to teach many people to start exploring with SQL, which is a pretty powerful thing.
And it doesn't even make sense nowadays to not make a data-driven decision in a company. Like, just your intuition might be good, but most of the decisions are now data driven. And
also all the traditional fields, I think, are revolutionized by like computer science totally, because like now it's an amalgamation of computer science with the traditional field. For example, marketing. Now we have digital marketing. So you no longer do like those traditional banner marketing, like you do like ad campaigns and stuff, but you do them on Facebook, you do them on Instagram, you do them on YouTube. And so like it's pretty great. Computer science is an integral part of like I think all the major fields. Okay,
now I think we should get back into DevOps because we are digressing too much. And so let's say like I am I work in the web development field, like with Angular, React, Node.js, sometimes PHP. Kritika works in mostly in the backend, and
Node.js
Node.js, Mongo, etc. Let's say we have to go into some kind of DevOps, because I'm sure that hundreds of thousands of developers like us, they know or have heard about AWS, Docker, Kubernetes, all of those fancy words, but they don't really understand, including us. And we know the basics, and we know that there's a team of DevOps in big companies, but in small companies, there's no team at all. Some experienced programmer in the company is handling everything. Either he's doing everything manually or using some automated DevOps. That's a different story. But yeah, can you just explain us what DevOps is and how someone can start jumping into that?
Definitely. So DevOps is a combination of two words, development and operation. So you two are working more on the development side. You're very familiar with that. So that's building applications. Operations is then taking those applications and operating them in such a way that your end user will interact with them. So for a web application, that's going to be deploying it onto a server, whether that server is one that you own, whether it's a server that AWS or Google Cloud owns, et cetera. And doing so in a reliable fashion such that you have high uptime, right? And so DevOps is kind of right at the intersection of those two things and how we can bring them closer together to improve both sides. So on the development side, we want to be thinking about where and how our code is going to be deployed, and that will inform certain decisions about what you write in the code. On the operation side, you want to be thinking about the types of applications that you're building and how you can best instrument them so that you have good metrics and monitoring and know if and when something's going wrong so that you can quickly address that.
Okay,
and so
when you say monitoring, sorry to cut you off, I just want to ask one question. So when you say monitoring, is it like, let's say my website is deployed and it's being used by a couple 100,000 people, and now the load on the website is too much to take? So with some DevOps techniques, would we be able to know that before the website crashes? Is that what you're...
Yeah, so monitoring usually refers to tracking some metric over time in the most general sense. And so for a web application, you might be tracking the CPU load on the server that you're using or the memory load. Okay. You might be tracking how many reads are going in from your querying your database at any given time. Yeah, exactly. Okay. And so by tracking those metrics and having some information about when you're approaching a red zone, if your CPU is starting to spike and now you're at 95%, whereas normally you're at 40%, maybe you can set off an alarm and figure something out before it actually topples over. There's a whole nother class of things that sort of go beyond monitoring called observability. There's companies like honeycomb.io. I did an interview with their CTO on my channel that was really great, where not just are you trying to track these sort of aggregated metrics like CPU or memory, you're actually tracking information about each request such that you can go in and, if you have an issue, really interrogate, was it this build versus that build? What time did it occur? Can you do distributed tracing? So in this world we live in with all these microsystem architectures, and you have your application split across 10 different things. It can be very hard to figure out what even is that request path and where did something go wrong. And so these tools, these observability tools, help you get a view into that where you can trace and figure out the exact set of conditions that caused a particular issue. And so that would be even one step beyond monitoring is sort of this concept of observability.
That's pretty interesting and a little overwhelming for a new for a person who just wants to start out. So what would be the first thing you would recommend me or other people who wants to get into this field? What is the first thing they should learn? Is it Docker or is it something else?
I think the very first thing you should do is, if you're already familiar with full stack web application, is have an application that you wrote ideally, or someone else if you don't have one, and work through the process of how you can get that to a place with a public URL that you can hit and view your web application. And no cheating, don't use Heroku, go spin up a server yourself, do it all manually, don't worry about automating anything, but just go through the process of okay, I have my application, it's in GitHub, it's a Node.js app, let's say. I'm gonna then pick my favorite cloud, any of them are fine, let's say GCP, AWS, Azure, Linode, Vultr, DigitalOcean, any are fine. Pick one. They all have free credits to get started, I think. So search on Google, find a link that'll give you $100 free credit, so you won't even have to pay anything. And then go through the process of creating a server. And so the funny thing is that within each of these services, they call their servers different things just to make it harder on everybody. So in AWS, it's called EC2. In GCP, it's a compute engine instance. In Linode, it's called a Linode. So figure out what that is, a server, and click the button to create it. You're probably going to then need to get your code onto that server somehow. So you're going to get SSH credentials or a root password and login. So you'll do that. And then there's a couple of ways you can get your code onto that machine. You could install Git and you could pull it if your Git repository is available. Yeah. There's a couple commands, Linux commands that you can learn to copy stuff. You could SCP it or you could rsync it. So figure out which one of those you want to do to get your code on the machine. If you really want to make it painful, you can retype all your code on the machine itself.
No.
And so once you have that,
imagine having one small error on your server, but not on your local machine. Oh my God.
I mean, just think about the old days where you had to physically punch cards to run your program. And so you have one hole in one punch card off by one, and you're out of luck.
That would make a perfect meme today for breaking your laptop and throwing it away.
That's right. So we just got our code onto this machine. Now we need to install any dependencies. So we'll probably, it's likely a Linux machine. So we'll have to look at, how do we, just like we did on our local machine, we're going to apt-get install some stuff. Then we're going to run the app. We're going to do Node.js, index.js or whatever. Then we're going to need to figure out the firewall. So like, how do we let traffic come in from the outside world? Once we do that, we should have at least a public IP where it won't be a domain, but it'll be an IP address that we can hit and view our web application. And so I think just working through that process of like understanding where does my code even run, right? Like a lot of people write code. And I remember talking to someone about this who was early on in playing around with programming, and they had gone through some Code Academy tutorials, and they were like, okay, I understand like if statements and for loops, and I can solve the questions that they asked me to. And I just do it in the web-based IDE. Yeah. But where does the code go? Right? Like if you're actually writing an application, I can write it and it does what I want, but then like, what do I do with it? And so I think just walking through those steps that I just described of manually figuring out where the code goes, and it's going to require a lot of Googling and looking at tutorials and following and adapting it to your specific situation, whichever cloud provider you chose. But I think that can give you just a foundation that then you can build off, and you could explore something like Docker or something a little more complex. But without that, I think it might be a little premature to jump in and try to start using one of these fancy tools.
Yeah, so the other day we were talking about, I think on the same topic with Mark Thompson as well, who goes by the name Mark Texan. That's his internet name. So we were talking about this, and we saw that how like people who just start like programming or coding, they just concentrate on like back end or front end, and they don't like understand the importance of like knowing how to deploy your application and like the importance of database as well. So that's what we like, the conclusion that we came on to was like, it's really important to know DevOps as well and the basics of DevOps, so that once you're ready with your application, you know where does it go. Yeah. So you won't ask where does the code go.
Yeah, and while I recommended that path as like a learning process, I still think once you've done that, it'll help you immensely if you choose to go with a platform as a service like a Heroku or an App Engine, because really behind the scenes, there's just a bunch of software that Google has written or Heroku has written that takes those steps that we just talked about manually and puts your code into the right configuration and executes them. And so
it's just an abstraction. So
exactly.
Once you understand the basic concept, I mean, you could do it on your own too. And also we used, I think, playbooks and GitHub Action to deploy our Discord bot. So we automated a few steps, but first we did it manually, but then we automated all those steps.
You were able to do a lot with your help in that episode.
Yeah.
Till date, I'm not able to do that myself, so I have to watch that video again just to
follow the steps.
Yeah,
that's the best when you come across something that you wrote or posted, and you're having the same problem a year down the road, and you say, "Oh, I don't know how to do this, but I know that I used to, and I know that it's publicly available for me to watch."
Yeah, that's great. That's great stuff. So whenever we think or like hear about DevOps, there's like two names that comes to mind directly. One is Docker and one is Kubernetes, as we already mentioned these names like a couple of times. And people often use like these two terms interchangeably. So what I want to understand is like, what is the difference between the two? If you could like just give a 2-minute brief explanation to in like a layman language to a person who doesn't understand anything. What's the difference between what's the difference between Docker, Kubernetes, and like in which situation you need to use like which one?
Yeah, there are very intelligent people out there who don't know what Docker is, so we just would like to.
So, yeah, that's a great question. I think people do get confused about where they fall in within all of this, and so Docker is a company, and that company really popularized the concept of containers, and a container is essentially a way to bundle up your application along with all of the necessary dependencies into a nice package that then anyone using a container runtime, Docker has its own container runtime, there's containerd, there's other container runtimes as well. There's this standard interface that if I take a compatible image that I built using Docker, so a container image, I can then take any of those container runtimes that I just mentioned and execute it. And so if you're familiar with object-oriented programming, the container image is like the class, and the container, the running container, is like the instance of that class. So I can take one image and make as many copies of it as I want and run those, and they should behave exactly the same given the same arguments. And that's the beauty of containerization, is that it allows me to have higher confidence that the environment that I'm developing in on my laptop or desktop is going to match the environment that I'm executing my production code on, wherever it may be running.
Okay, so just to understand a little more, because I'm starting to get a little confused, and I'm sure some people will also get a little confused already. So by container, do you mean that obviously it's not a virtual machine, but can we say, just for understanding, that container is kind of a machine that contains everything that is needed for your project to run? Is that a
yes,
really good
I think,
explanation, or totally wrong?
No, that's a fair explanation. I think there are critical differences between containers and virtual machines, and that's the layer at which you're sort of separating things. So virtual machine is virtualizing the full operating system, whereas containers, they are sharing one kernel using some concepts in Linux called C groups to allow it to set what access, or basically how much resources it can use, and then namespaces to isolate it from other processes. The degree of separation that you get from a virtual machine is higher than the degree of separation that you get from a container, but there's more overhead in virtualizing all that stuff. But yes, like in layman's terms, you can think about a container as sort of this isolated box in which to run your application that contains everything it needs.
So all these containers, they run in the same machine?
You can run multiple containers on one machine, yes.
Okay, perfect. And so, yeah, go ahead.
But you can distribute them as well onto like different machines. So like different machines are running different containers of different images. Something like
Correct. So I can, on my laptop, issue a command to run a container. I can then log into that server that we just provisioned that I was describing earlier and run a command and use the same image tag, and it'll be running in both places, and it should run the same way, and that's great.
And is it also easier with containers to share a code? Let's say I am using Linux and someone is using Mac and the other person is using Windows for some weird reason. Just kidding. So will a containerized project help with that? Or is it, I'm confusing two different things now?
it certainly helps, I think, with collaboration in that sense that most containers, what's running inside the container is Linux. And so if I'm on a Mac or if I'm on Windows, then Docker, the software that I install, is actually going to have a virtual machine running Linux that the container then gets run in, because you can't run a Linux container on Windows natively, or on Mac natively. And so
that's where the Docker desktop comes in, I guess.
Exactly. So it gives this really nice interface such that I can take that image and pull it to Windows, Mac, or Linux and have it execute nearly identically. On Linux, it'll run natively. On Mac OS and Windows, there's a virtual machine that Docker is managing that you don't have to think about, that will actually execute. That's where the container will get executed.
Okay, so I have another question, a follow-up question with that. And I'm sorry for asking so
No,
many
this is
questions.
great. We'll get to Kubernetes eventually.
Yes, exactly. Yeah. So let's say I have, so let's say now I have containerized my application. I'm using Docker, but another person using the same project does not like containerization. So what is the disadvantage of not using something like Docker? Like, will my project still work, or will it be very slow to work with or deploy anything now?
So I have to ask you questions to figure out more about the situation, I think, to answer that.
Okay.
Because you can do local development with Docker, where you can be running your container and you can what's called mount your file system in, such that when you change code, it'll automatically change inside the container. You can also do local development, not in a container, and then build your container in CI/CD, etc.
Okay.
So it would certainly be possible to have two people working on the same project, one developing in containers and one not. I think having that discrepancy is not a good idea, just because you'll have the likelihood that eventually you'll have some incompatibility between, let's say, the Windows-based version of a Node.js library and the Linux version of that same Node.js library, just slight incompatibilities that might come back to bite you. But it is entirely possible.
And what are the disadvantages of completely not using anything like Docker?
Yeah, so not everyone uses containers. I think it varies from language to language. Some languages are better suited for containers than others. I think if you look at a language like Java, where you have the Java runtime environment that is meant to help with cross-platform compatibility, containers become slightly less necessary, right? They also, because you're executing everything in this big runtime environment that is quite large, it makes all of your containers quite large. Versus maybe like a language like Go, which is really designed for microservices, and you can build these web applications and compile them down into a static binary. You can make your containers super small. Like once you've compiled it all, you can then copy that into essentially an empty container, and it can run all on its own. And so then your containers might just be 10 megabytes or even smaller, versus a Java container might be gigabytes, right? I think depending on the language, there's trade-offs. There's always trade-offs. Some are more well-suited, some are worse suited. It's all just decisions.
Okay, I'll allow Kritika now to finally go to Kubernetes. I think I have taken a lot of time on Docker.
So you have to answer the question. So like, what is Kubernetes? How is it different from Docker? But like, what I understood is, I read about it a little bit, like on internet. And so is it like, if we run Docker containers on like different computers, and if we have like a distributed environment, that's what Kubernetes is, right?
Yes. So earlier you asked, could we run multiple containers on one machine? And you asked, could we run these containers on multiple machines? Exactly. The answer to both of those was yes. We also can do that. We could do that manually, right? Like I can issue Docker commands on my laptop. I can issue Docker commands on that server. I can issue Docker commands on a different server. If you get to a certain scale where you have lots of these containers running, like let's say I just had one or two things, then I'm probably just going to run my Docker command, or maybe use Docker Compose to spin them up on a single server. But when you get to the point where no longer everything fits on one machine, you want to start scheduling these containers or deploying these containers across multiple machines. You want to start having some automation around making sure that they're healthy, and like maybe you have a health check that it's pinging every few seconds, say, is my application still alive? If not, can I try restarting it? When you start to add all of that complexity into your system, you could do that all manually, and you could have little scripts that are pinging it every so often. But that's when you start to look into what's called a container orchestrator. And so Kubernetes is a container orchestrator. There are others. There's a product called Apache Mesos, which is not a container orchestrator, but it's an orchestrator in a similar sense. It takes multiple machines and turns them into one cluster. And so all of these container orchestrators give you an abstraction over multiple servers, they might be virtual machines, they might be physical servers that you have in your data center, and gives you that abstraction layer so that I can no longer think about, I need to schedule one copy of my application on machine number 5. Instead, I say, give me one copy of my application, and then Kubernetes, or the container orchestrator that you're using, figures out which of your 5 machines or n machines has capacity and schedules it there and does the health checking. And let's say if I release a new version, Kubernetes has built-in functionality to allow me to roll out, if I have 5 copies of my application running, I can upgrade them one at a time, and it'll actually like bring up a new one, tear down one of the old ones, bring up a new one, tear down another one of the old ones, and do a blue-green deployment or other deployment strategies. So Kubernetes is all about, it's almost like an operating system for multiple computers all at once in the cloud, is one way to think of it.
So is there a compatibility issue between them? So like, can we use any container orchestrator with any container structure, or do we really need to use like 2 specific ones?
So there is this standard called the OCI, the Open Container Initiative, which developed a standard for what a container is. And so Docker images that you build conform to that standard. And so as long as your container orchestrator has a container runtime, which could be the Docker container, or the Docker desktop has its container runtime. Containerd is another. I think Cryo is another. As long as that container runtime adheres to that same standard, you should be okay in terms of being able to run it on that system.
Okay. Well, my mind is now kind of blowing off a lot of steam because you are explaining things in a very nice manner, but still some concepts are just, flying on the top of my head. And I think I'll have to rewatch this, read some more things, and then I will be able to understand more, to be honest, because I do get the point that the questions Kritika is asking about what Kubernetes is, what Docker is, why containerization is helpful. But I think that me or any other watcher of this video who has never seen or worked with Docker or things like that, or any kind of DevOps, will need to go through and read a little before they could understand each and every concept. So to the audience, if you're not understanding everything, I'm with you.
The other thing is that Kubernetes itself is a very complex system with many moving parts.
Yeah.
If you are trying to deploy and manage that all yourself, it can be quite a large task. Many of the cloud providers now have a managed offering where you offload the responsibility of actually dealing with the cluster. And so Google was the first to release one. It's called Google Kubernetes Engine. Amazon has their Elastic Kubernetes service. Azure has a similar one, et cetera, et cetera. And so you can sort of leverage their expertise in managing the system side of things, either via the UI. You can click and get a cluster in a couple of minutes, or you can use a tool like Terraform or other infrastructure as code tool to spin that up. And then you can really focus on the application development side, where you build your application, you build the container image, and then you can specify, okay, run 5 copies of my app, and then hand that off to the managed Kubernetes system, and it will go off and do that. And so I think that can be a good starting point for someone who is getting started with Kubernetes to not think about deploying the Kubernetes system itself, and more so using it as a platform to deploy their applications.
Yeah, that's really good to know.
Interesting. So the other day I was going through all your tweets, and I found a very interesting one, which said that yes. So yeah, I found a very interesting one which said, what even is DevOps? And the most intriguing answer was from you. You said, so first of all, the tweet mentioned you wanted wrong answers only. And the most intriguing wrong answer was, you said that DevOps is a portmanteau, I think, of devilish and opposition, so like DevOps, and it's only meant to slow you down. So that's what you said. So I want to understand. So like I'm sure like you must have heard a lot of misconception about people have about DevOps. So what's the most common misconception related to DevOps that you've come across?
Yeah, one of the most common is that people think that you can build a DevOps team or hire a DevOps person and then you are doing DevOps. Really, that's not the case at all. Really, DevOps is about how you take your existing functions of who is building the application, who's operating the application. In a small company, those might be the same people, and how you empower them to build the software better and operate it more reliably. And so, yes, you might have someone who has DevOps in their title, and a lot of people like to debate whether or not it is a true title or not. But you really should be focused on what practices you can implement to make the lives of the technical team members who are building and operating this application better, and reduce the manual toil that they have to go through in their day-to-day process.
Okay. No, so that's really true, because DevOps really do make the lives of programmers very easy. And like without it, I think we would just pull out all our hair. Like, definitely.
Yeah. So if you can add improved test automation such that bugs are caught earlier, if you can add monitoring to your deployment stack so that you can figure out when something's going wrong and dial in exactly where in the code base is causing that. If you can, there's just all of these things that you can add, and sometimes it's not adding, sometimes it's removing, right? Sometimes there's issues that you want to remove. And so what DevOps really is about for me is trying to find bottlenecks in either the development process or the sort of the team side of things, or on the technical side, bottlenecks with application performance, and prioritize those into which are causing the most issues or wasting the most time, and then addressing those systematically to help improve the efficiency of the team.
Perfect. So I guess you're one step ahead of me, because the next question I wanted to ask was what DevOps really is. What's the right answer? So you already answered that.
Yeah. And so when you are not containerizing things, now let's just make the conversation a little lighter with this question, because we have some serious questions for you later. So what do you do? Like, what are your hobbies? What do you like to do when you're not containerizing or making awesome YouTube videos?
Yeah, outside of making videos.
Yeah, so video production and content creation has become a hobby, which is nice. I do enjoy fitness related things, so lifting, and I do CrossFit, which is a lot of fun. Enjoy getting outside and doing hikes, and also anything to do with sort of fitness and sports. I have always enjoyed. I really miss the competitive aspect of competing in track and field back in high school and college, and so having things where you can stay active and get outside is a lot of fun. I know you two are big hikers, right?
Yeah, we are actually going day after tomorrow. We are going to Banff for a week, and we are planning to do a lot of hikes over there.
Yeah, and our schedule is every day get up at 6, go for a hike.
Yeah.
Nice.
That's all we know.
Have you been to Banff?
I have not. I've heard good things though.
Yeah, it's really awesome, and you should also visit Quebec whenever you come this side. There are a lot of hikes, and it's really beautiful.
Nice.
Yeah. Okay, now let's get into the difficult questions.
Before that, I think you want to move into the last section, but like before that, I have another question. So actually I have 2 questions. So I'm gonna go first with the easy one. So recently we had Francesco, from his channel, like he's a fellow YouTuber as well. You know him. You've already done an interview with him, I guess, on his channel. So he was with us, and we on the podcast, and we talked a little bit about like how he became a Docker captain, and what a prestigious title it is. Like, we didn't know there exist only like 30 Docker captains in the entire world. I mean, it was really a shocker.
When I first came to know that he became a Docker captain, I thought, okay, so it might be like a certification that he can pass by just giving an exam. So I didn't think that it was a big deal. It was a big deal for me, But I thought that everyone in DevOps need to become a captain someday.
We didn't. We couldn't estimate the, I don't know, like the
depth of
the magnitude.
The magnitude of like how serious.
Just 30 in the whole world. I mean,
it's great. So the question is, so like, do you have something similar in mind for yourself? And like, do you see yourself following that route in the future?
Yeah, so I think there's a lot of titles like that. There's Docker Captain, there's Microsoft MVP, Google Developer Expert, Amazon Heroes. I think Terraform has their own title. I have not actively pursued those. I think that it is something that I may do in the future, but I have not applied for any of those programs yet.
Okay. That's interesting. Kritika, we need to get one of the titles for us. It would look good, you know, like...
in the background, we're going to put like a wall of fame, and we're going to put a title.
Angular King, Docker Queen, something like that. That sounds good.
Nice. Yeah. I mean, I think it certainly would be helpful in establishing credibility when working with new clients or applying for new jobs.
For sure.
But I have not had too much of an issue establishing that credibility without them. So I think while it would be beneficial, I have succeeded without it thus far, and so it hasn't been a priority.
But do you plan to move into YouTube full time someday, or do you enjoy your current schedule, your current work-life balance? Like, you make YouTube videos as a hobby and...
Yeah, I like my current balance. I think of myself as an engineer first and a content creator second. I think if I were to go full-time on content creation, I would quickly lose touch of what really matters in terms of the technical side of things. And so having one foot strongly in the technical domain and using that as a way for me to continue to build my skills and know what is most relevant for the content that I produce, I think is an important aspect. So never say never, but my current plan is to keep this split.
Okay,
that's great.
That's very good. That's
great. So the other question before we move on to our last section of the podcast is that you've worked in both the fields. So you've worked as a mechanical engineer, and you're now working as a DevOps directive, as a DevOps person. DevOps engineer. Do you say DevOps engineer?
I just say software engineer with a DevOps focus.
Okay, so you're now working as a software engineer with the DevOps focus as well. So if you don't mind me asking, what's the average salary in both the fields, and like which one is like more lucrative?
Between mechanical engineering and software engineering with a DevOps focus. I think software engineering definitely has a higher salary, especially here in the Bay Area. A big portion of that is just the types of companies that are hiring. So you have the Facebooks of the world and the Googles of the world here that, yes, they may have a few mechanical engineers, but they have a lot more software engineers, and the competitiveness of all of those companies trying to get the best top talent has driven up salaries to kind of crazy amounts. And so, I mean, I think there's a site called levels.fyi that has some good data around engineering, mostly software engineering salaries in various locations. And so people can go check that out for the types of salaries that people make at those types of companies. And it's kind of crazy, and you'll probably feel bad about your salary after going there. And I feel bad about what I make after going there, but at least it gives some data around what these people are making at those types of companies.
That's true, because when we were in India, the salaries that used to look lucrative to us, we wouldn't even, think about them now, because it really differs from location to location. And like when I was in India, maybe I told you in our last collaboration, my first job was for $6,000 for 1 year, and my goal was, if I can make $20,000 in a year, that's like more than enough. That's gold. And that's true. Like the website you mentioned, I will go on that, and I will also put a link to that in the description below, because people from all over the world, they might, it would help them get a perspective on what this field can actually offer based on if you're actually willing to go out, travel, and explore more, because it's really amazing how different it can be from your city or country to another one.
Definitely. And I think as the world becomes more remote, it'll be interesting to see how the market shifts or changes. I think as people have left San Francisco due to the pandemic, and some are no longer coming back, and some companies have moved to a remote friendly or a remote forward policy, there will be shifts, I'm sure, in compensation, where some companies will then say, oh, well, now you don't get the San Francisco salary anymore.
Exactly.
And I think there will be
Vegas a lot.
Yeah, so I think it'll be interesting to see how things evolve over the next few years, for sure.
Yeah, definitely.
All right. It's time for the final section of the podcast, and we like to call it the Coders Quatro.
Coders Quatro.
So we're going to ask you 4 questions, and these are the 4 questions they're the same questions that we ask all our guests.
Yeah.
So first one is, what framework / technology / language do you think a new developer should learn today?
Yeah, so if they are just getting started, want to learn programming, I think the fact that JavaScript can be used on both the front end and the back end makes it extremely powerful as a tool to start building systems. So you can get started with JavaScript, build out a nice looking front end that has cool interactive elements. You can use Node.js on your back end to build out your APIs. And with that single piece of technology, you can build out a solution to many, many different potential problems or applications.
And now you can even make mobile applications, native mobile application with JavaScript. That's exactly my answer. JavaScript is not my favorite language. I kind of don't like the language, but I really like it because it's so powerful. You can almost do anything with it. I mean,
Yeah, that's our most popular answer.
Yeah,
JavaScript.
That's true.
If you only get one, you gotta make the impact across as much of the stack as possible. So
exactly.
Yeah. I'm looking forward to the day when someone says something like C or those languages that we used to learn in our college.
In school.
I think it would be interesting if without more context. I think JavaScript is a great answer. If you had a more specific goal in mind of where they want to go or how they want to use computer science, I think that might lead to some other answers.
Yeah, the thing is, usually when people are just starting out, they're usually just thinking that this is a lucrative field and they would get a job. So they just want, the technology or the framework that would help them get a job in the end. And that's why everyone kind of thinks about JavaScript, because it's kind of very widely used, and front end, back end, mobile development, everything. But yes, with context, maybe C or C# would be a better fit. Okay,
exactly. If their interest came from something like robotics, or they want to go into embedded systems, then you definitely don't want JavaScript in that case.
Yeah.
So.
Okay, moving on to the next one.
When you want to learn something new, what do you prefer? Do you prefer watching videos, or do you prefer reading documentation?
I prefer reading documentation, which is interesting because I make videos. So videos are great for very specific purposes. So if I cannot figure it out from the documentation, and I can find a video that is close enough to what I'm trying to do, it can be very helpful to see the entire process end to end. Whereas documentation, inevitably, there will be some step that gets skipped or not written out in detail, etc. But for me, it's faster generally to look at the documentation first and then maybe use a video as a fallback.
Okay, so the next question is question number 3. Do you think going to college or university is important in the context of computer science, like to excel in the field of computer science? Do you think going to a college or university is important?
It certainly doesn't hurt. I think it is also not a prerequisite to succeed or be successful in the field. So I think my college experience was very valuable. Even though I didn't study computer science, it helped me to develop a framework for how to think and how to learn and how to solve problems. And those 3 things together are super powerful when trying to build software systems. Because as we've talked about in this discussion, there's just so many topics to learn and explore that the faster you can pick them up and apply them to your specific use case, the better you'll be as a developer. So I think it certainly does not hurt, but it is also not a prerequisite.
Okay. Okay.
Yeah, that's true. And we've seen so many examples of people like who've excelled in the field of computer science by just attending coding boot camps and like developing something great. So yeah.
Okay. The last question, and it is the most difficult question, and you really have to think a lot. So, what's your favorite programming language?
My favorite programming language right now, I would say, is Python.
Python. Oh, that's
And why
interesting.
is that?
I think it is very readable, and you can build things very quickly with it. I have been using it quite a bit with one of the companies that I work for, so it is also the language that I am using the most right now.
Okay.
And yeah, it's just I think it's
Do you,
more easy to work with than many other languages.
okay. Do you think Python has like a smaller learning curve, or is it like more beginner friendly than JavaScript?
I think it is easier to read Python than any other language, just about. Like you can look at it, and even if you don't know anything about programming, the words make sense, and you can kind of logically read through what's happening. JavaScript is pretty readable as well, but when you jump into some languages without additional context, it's gibberish, right? Whereas I think JavaScript and Python are both pretty approachable in that sense.
Okay, perfect. Thank you so much for coming on our channel. And we have one final request. Can you please tell the audience to hit the like button before they go?
Everybody, there's a button. It's going to be over there. So hit the thumbs up button, and then there's another button next to it. And if it's red, then you need to click it. If it's gray, do not click it. So just do those two things. And then just whenever you see the Immigrant Programmers pop up in your feed, you have to click on it, but then you have to leave it playing all the way through the end. Don't click off, and then you'll be done.
Important.
That's amazing. And also comment down below. Tell us how you like this video. And we're going to put all the social handles for the DevOps Directive set as well down in the description.
Yeah. So if anyone wants to learn Docker or, pick his brain on some problem in Kubernetes, you know where to find him.
Yeah.
And
Exactly.
yeah, it has been great. Thank you very much.
Yeah. Thank you so much for having me on. It was a fun talk.
Yes, we learned a lot about Docker today. I'm sure we're going to containerize something.
Exactly.
Perfect. Thanks.
Okay,
Take
bye.
care. Bye.
Take care.